So earlier we spoke about the babysitting of the learning process part, where we said, okay, we need to find these good hyperparameters. Random search happens to be a good idea. But then suppose we do a random search, and we then in our random search, let's say, have a set of parameters. Which one of them is best? How do we judge which of these hyperparameters are best for us? So how do we set these hyperparameters? For example, we did the nearest neighbor. There is also this thing called as the k nearest neighbor, right? What you do is you find the k nearest neighbors. Let's say we have a bunch of points, yeah, and let's say this is point 1, point 2, point 3, and so on. And let's say we get a query point, right? So this is what we are querying. So what we do is we find, let's say we are doing like 2 nearest neighbors, 3 nearest neighbors, right? So we're trying to find, let's say, these. So we draw a ball of, let's say, this size. So the goal here is to ask, like, how many nearest neighbors do we want? In this case we said, okay, maybe 2 nearest neighbors are good for us. What do you do with these nearest neighbors is another story. For example, you could just average them out, right? The simplest thing to do with any statistical measure. So, but the question here that we are trying to answer is, what is a good value? What is the best value? How do we decide what hyperparameter should we use? What is the best value of our learning rate lambda? What is the best value of the number of layers? What is the best value of this k for when we are doing k nearest neighbor, right? And the answer is that it is very problem dependent, and we must try out all and see what works best. But try out where, right? Like, let's say we say that maybe we have tried k equals 2, 3, 4, 5, but then where do we try to see that it works best? So one lazy thing we can do is we can maybe create our training set and then keep a little bit of that data that we have collected and call it the test set. So let's say this is 80% of our data and our test set is 20% of our data, right? So we can maybe just try our hyperparameters on the test set, and then we say, okay, which k gives us the best numbers for our test set. Okay, so this is a reasonable, let's say, strategy, and it's okay to do this, at least initially. In fact, we in practice do this all the time, but it's a bad idea when you're kind of trying to generalize, right? So when you're really trying to generalize very well in the real world, this is not the best strategy. Why do you think so? It is because then, though you're not filling, so with the training data, you're actually updating the weights of your model, right? You do the derivative of the loss with respect to the weights, and then you actually go and update this, right? You take a learning rate and you do all that jazz. So your training data is used to update your real weights. But what we are doing when we are doing this hyperparameter business is we are actually fitting our hyperparameters on our test set. So we are fitting our lambda on this test set. We are fitting the k on the test set. And that's usually a bad idea. You see why? Because now we are overfitting the hyperparameters on the test set, and this can have implications to our generalization performance, meaning when we deploy our model in the real world. So the good practice is to kind of use this test set very sparingly, only at the end. But you do use it in the end, right? But you have to use it as little as possible, because as soon as you run your model on your test set, you get some evidence, right? You're like, okay, maybe this works well, this doesn't work well. And then if you use that feedback to change the hyperparameters of your model, that means that you're overfitting your hyperparameters on the test set. Yeah, so your test set should really be a representation of your generalization performance, of your real world performance, what the model will get to see when we unleash it in the real world. And for that reason, you should use this test set very, very sparingly. So then what can we do? So we can do this thing called as cross validation. Yeah, it's just a fancy word, so they call it cross validation. Yeah, and what it means is you will create multiple, let's say, folds of your training data. Yeah, so you leave your test data as is, you don't touch this, but your training data, let's say we are doing this thing called 5-fold cross validation. So all it means is you will divide your training data into these 5 sets, and then you will use this one set, any of the one set, let's say in this case the fold 5, to fit your hyperparameters, to find the value of k, to find the value of lambda, right? And then whatever is the best value you get, for whichever value you get the best performance on this data, that is what you will use to then test on your test set eventually. But you will not do this only for the fold 5, so you will use this as your validation data to tune our hyperparameters, like I said. But it's not just fold 5. The next time you will use fold 4. The next time you will use fold 3. So by next time, I mean the next time you train a model. So all of these are a training run, right? You train a model and then you fit it onto, let's say, fold 5. You train a model and you fit your hyperparameters onto fold 4. And in this case, you're reducing the training data size, meaning you are only using this much data to train your actual weights, your parameters, right? Your learnable parameters. You're using this to find the values of your hyperparameters, right? Your hyperparameters. And this is a proxy of your generalization performance, of how your model will perform in the real world. And we do this more often when when the training data is not that big, and usually in practice what we do is we don't do this cross-fold, this cross validation, this multi-fold cross validation. We don't really cycle through the choice of which fold and average the results. So what can happen is, here you get, let's say, when you test on this, when you fit your hyperparameters on fold 4, you get k equal to 4. When you do your fitting on fold 5, you get k equal to 6. On fold 3, you get k equal to, let's say, 2. You average these 3 out and you get your value as 4, and then you use k equal to 4 to then run our model on the test set. Yeah, but in practice, sometimes we are lazy, sometimes we don't have the capability to train the model so many times, because each training run might cost us like $20,000, $100,000, and for let's say bigger companies it might cost them even more. So in that case, we don't do this cross validation business. We just have one validation set, one test set, and the training set, and we kind of just fit our hyperparameters on that one validation set. And then once we are happy and we have kind of tested it enough, we then test our model on that final test set. And that's all that you need to know, how to fit your hyperparameters on your data. So remember, you do not tune your hyperparameters based on your training set, because that would mean that you're overfitting on the training set. Your model can cheat, it can overfit, it can basically latch on to these so-called high frequency noise, right? It will try to short circuit, it will try to cheat as much as possible. It will try to find those very high frequency details which we don't want it to overfit on, right? So you don't fit your hyperparameters on the training set, you fit it on the validation set, not on the test set. I mean, we can do it if you're lazy, but we don't do it on the test set. Why? Because that is the only, let's say, proxy for real world performance. So we use it very, very sparingly, right? So that's all that there is in cross validation.